In this question, you have a ball coming in from left to right, from right to left. It's struck by the bat, and then it goes upwards at an angle of 35 degrees at an increased speed as well. Now, you're asked to find the impulse forces from the bat on the ball, so you're going to have to look at the momentum coming in, the momentum coming out, and look at the force imparted by the bat in its components x and y. And we're also making the point that during the small interval of the collision, you can consider two separate forces, the force from the bat on the ball and the force due to the weight of the ball. Now, of course, the force from the bat on the ball is going to be many times greater than the force due to the weight of the ball, and so we refer to the latter as a non-impulsive force, i.e. the weight is a non-impulsive force during the collision, whereas the force from the bat on the ball is definitely impulsive as it drives the momentum exchange. Okay, so the first thing to do is to work out the vector form, since we're dealing with a 2D problem, of the two stages of the motion. So initially we have flow going from right to left, convert that into meters per second, we work out that our v1 vector is minus 37.6 I. Then v2 is directed above the horizontal at 35 degrees, so we can work out this is 47.8 I plus 33.5 J. And then we can apply the impulse momentum equations in both components. So doing that first in the x direction, our impulse is going to be the difference between the final and initial states of momentum, or more simply m times v2x minus v1x, where fx is the force and delta t is the interval over which it acts. Given the mass of the ball, we can work out that the impulse in the or the force in the x direction from the bat on the ball is 2,490 newtons. Now, doing exactly the same in the y direction, we can see that the force Fy of the bat on the ball is times by the interval delta t is equal to the change in momentum in the y direction. Now it comes in with a zero momentum in the y direction and leaves with a vertical component of the velocity. So, considering this, we have the mass of the ball times its exit velocity in the vertical direction. And at this stage we can say that this times this divided by this gives us 9,077 newtons. And we can see that these are the sum of the forces due to the force due to the bat on the ball and the force due to gravity. So if we look in the vertical direction, we've got Fy, and we've got a tiny force due to mg. Now the point is that Fy comes out at 978 newtons, while mg is just under 1.5 newtons. So you can see this is many, many times greater than this one. So during the small interval of the collision, it's entirely reasonable to neglect weight because it's a non-impulsive force. Whereas during flight itself, then you absolutely have to take into account the weight because it's responsible for its eventual projectile motion. So it's something to take note of.